Very good morning, everyone. And today I will present proposed work design of a blockchain-enabled secure vehicle-to-vehicle communication system. I Devashish Das from University of Kolani, India, and these are our co-authors. Our proposed work basically blockchain-enabled vehicle-to-vehicle communication systems, where blockchain can be implemented in the vehicle-to-vehicle communication system, some for the easy applications and secure platforms like the communication interface, secure data storage, etc. And vehicle-to-vehicle communication system basically for the network and the easy traffic congestion and enhance the passenger safety, etc. And blockchain can provide a secure platform where B2B B2B in the B2B communication system, vehicles can communicate with each other securely. Blockchain is an open distributed ledger where multiple authorities can communicate with each other using transparent database, and it is efficient and verifiable. All the transacted data in the blockchain can um, validated by all the nodes in the blockchain network, and the blockchain data basically is permanent, so the information is stored in the blockchain is persistent. For issues in B2B communication system are user privacy. Basically, many B2B communication systems are based on centralized systems, so there can be a user privacy. And platform security, where platform basically centralized system is not enough secure because of private third parties and basically hacking issues, etc. And data security, data also the data is stored in the centralized system can be shared with the third parties and no one can know about this. So another issue is data transparency. What is the data is stored in the database, so user don't know about the transaction and what malfunction are happening in the centralized database. Another issue is secure interfaces. This is our proposed framework, blockchain-enabled secure vehicle-to-vehicle communication system. It is a secure, centralized, decentralized, and transparent framework where it can enable high speed and high frequency information sharing platform where vehicles can securely share the data like vehicle speed, vehicles movement, and slowing. Vehicles are slowing down or very fast. So vehicle speed. And in this scheme, automatic authentication scheme is provided to identify the vehicles and to authorize driver or passenger drivers or any another vehicles order using smart contracts. Vehicles can communicate with each other through blockchain network using CB2X technology. CB2X means cellular vehicle to everything, and it is two type of communication can be done using CB2X technology. One is direct communication and another is network communication. In the direct communication, we don't have the blockchain. Just vehicles collect information from the blockchain and it can directly communicate with other vehicles. And when vehicles collect data from the blockchain, so there is a need network connections. And in this scheme, vehicle can communicate and access and receive data from the blockchain, and therefore it can verify itself also, and it can verify another vehicles using blockchain and smart contracts. This is our system architecture where Basically, there are different zones where multiple vehicles can run, and therefore, and this is a zone 1 vehicle where every vehicle can communicate with each other directly using CP2X technology, and another zones and vehicles data can be collected using cellular link, and this cellular link connected with blockchain data pool, and blockchain is connected to the different node. So this is a transparent architecture. Implementation of the proposed work and vehicle identification test. At first we need to identify vehicle, therefore their user, and therefore user authentication stage, and finally vehicle communication stage. Communication stage. Vehicle identification stage to identify vehicles. Each vehicle has a unique ID, and this ID uniquely identifies vehicles. Each user can hold multiple vehicles. So for the multiple vehicles, there are multiple UI for different vehicles. Shared data between vehicles will be stored in the blockchain using their UI. So vehicles can communicate with other vehicles using their UI. So another vehicles easily identify the vehicles. Authentication to verify genuine users. Basically, blockchain application is managed by the vehicle user owner, basically a user. So user can verify smart contract automatically. Therefore, no unauthorized access can be detected to the blockchain application as well as vehicles. In the B2B communication stage, C2X and CB2X can easily share their data using UI, and there are different algorithms are presented to identify the vehicles, authorize the users, and communicate with each other securely. B2B can connect and transmit data like vehicle speed, vehicle position, vehicle and heading and acceleration and slowing down information, etc., and many more. And it can be and the data can be collected from the another zones using cellular CB2X technology. And in this proposed system, each vehicles have their UI CB2X chipset, sensor device, and onboard unit to establish communication with each other. This is our proposed workflow diagram. Each vehicle has a UT, and smart contract randomly generate RT, basically a random token, and UT is the user token. So is a user valid or not? So it is checked by the smart contract. If UT is available for that user, so smart contract generates the RT for the user, and therefore user provides UT and RT to the application. If the UT and RT are valid, then user is authenticated. Otherwise, the user is not authenticated successfully, and a notification will be sent to the another and to the user. This is a B2B communication system using blockchain, and how it can be implemented. A simple scenario is here. What is the key management strategies? Key management strategy basically depending on identification stage and authentication stage and communication stage. In the identification stage, unique how to generate unique key using blockchain cryptographic hash functions, and it is included blockchain account address, user license number, vehicle engine number, vehicle chassis number, and vehicle number plate. Combining these, we can generate unique ID for each vehicle. In the authentication stage, basically UT means user token. User token is set by the user, and random token is set by the smart contract. and therefore user should provide the UT and RT to authenticate himself to the application. And random key is generated using blockchain account address. For the blockchain account address, it is the user account address, and therefore user license number, timestamp value, and vehicle numbers. In the communication stage, each vehicle has a secret key to communicate with each other, and secret key is generated in the same way using cryptographic hash functions, and it is included unique identification number UI, and therefore random token number, and vehicle number, and therefore timestamp. And secret key is basically different in the different session. Whenever a vehicle try to connect with another vehicles, at that time secret key is 1, and after 30 minutes or after sometimes after the vehicle try to again connect with another vehicle, so that time secret key will be different. Proposed algorithm, we have proposed 3 algorithms here. One is user authentication algorithm, another is the vehicle authentication algorithm, and as well as unauthorized access detection algorithm. And secure communication established between vehicles and another algorithm where secret key is required. And when vehicle authentication is performed, user authentication is very necessary to identify the vehicle's security, and to establish the vehicle security and to provide the vehicle security, user token, random token, and unique identification ID. This is our practical scenario. Smart contract functions is created. What is the significance of BSVCS? And it is provided transparent, secure, and privacy preserving framework where multiple authorities can collect and share their information using blockchain. And here provide a secure user authentication schemes, provide a unauthorized access detection, provide efficient key management system mechanism, and it provides basically the security of vehicle. Conclusion: blockchain is a low risk technology, and it can be deployed anywhere for the security issues and many more, and anonymity and efficient like decentralized platform it provides, and it's secure, decentralized, and open communication to resolve the different concerns associated with existing other vehicle-to-vehicle communication systems. So an automatic vehicles user authentication and a secure B2B communication mechanism is provided here in the proposed systems, and it's also provided stable and economically B2B communication system is provided securely for the intelligent transport system, and it can also profitable for the transport systems. And basically autonomous vehicles are main profitable platform using this proposed work. In the future, we can extend it performance comparison with other technologies with more parameters, and like and throughput, and like practical scenario like and autonomous vehicles can be included here. So in the autonomous vehicles it can be more useful. This work will be extended by developing the complete implementation process. In this session, in this paper, we didn't provide the whole things for the lack of page extension, so it can be provided in the future. There are some differences for the proposed work.